All right, welcome back, everybody. First, I'd like to introduce our next team here for check-in. It's Team 2337, the EngiNERDS. They're from Grand Blanc, Michigan. Why don't you guys introduce yourselves to everybody at home?
I'm Clinton Bollinger. I'm one of the co-lead mentors of Team 2337.
I'm Alexis. I'm co-team captain and operator interface student section leader.
I'm Gus. I'm the head of communications and a senior programmer on the team.
Cool. Well, guys, welcome to the show. Thanks for coming on this evening and talking with us. So let's no problem. So let's talk a little bit about how your week's been going. Give us an update as to where you are for this week.
It's been going pretty well. We've accomplished a lot of our goals. So we got a lot of machining that we wanted to do done last weekend. And then last night we were able to send off some of the parts we want to WaterJet. So it's been going pretty well this week. Our main goal for the end of this week is to try to get a practice robot ready that has our gear intake on it, a field intake, the gear mechanism, and the sides. That way we're able to get a moving chassis and try to practice driving, that kind of stuff.
Wow. So your plan is to already have a robot like doing most of the game by this weekend?
Absolutely.
We hope so.
Wow.
The only thing we'll probably be missing is probably the shooter and fuel tank for our robot itself.
Cool. Wow, that's awesome. So I got to ask, how achievable do you think that goal is? I know you guys said you met your goals for this weekend. Is there lots and lots to do? Is it going to be a push to the end to get it ready, or you guys think it's going to be a shoe-in?
I think that with what we have so far, that at least for the most part, we'll be prepared for bag day. Definitely.
Well, I mean, WaterJet should be back tomorrow.
Okay.
So with our WaterJet, we have two robot parts going out. One of them will come back to be sent off to powder coat, as well as our competition chassis sent off to powder coat. And so this weekend will be electrical wiring. The intake is already machined. They're actually assembling it downstairs right now. And then we got to do a lot of work on the climber and gear mechanism, but hopefully by the weekend we'll have that going.
Cool. Well, I mean, that'll be good. And you'll have a platform to test it on and see how it all works out too, and make improvements for your final robot. Very cool. All right. So let's talk a little bit about, now that we've got an idea of where your robot is, let's talk about the software and controls for your robot. So what kind of sensors are you guys using? How is your robot going to navigate the field and control itself? What maybe are you using vision at all? What's you guys planned so far for the year?
So right now, we are using a lot of different sensors. We're using mag encoders, which is like magnetic encoders. We're using cameras for vision. We are going to be doing vision. We're using different gyros. So last year we used Navex, and this year we're kind of testing different gyros, like the internal on the RoboRio, and Pigeon is another one that we're testing to see like which one would work the best. We're doing like testing on that right now.
Interesting. So why did Navex? That's got like a lot of bells and whistles on it, doesn't it?
I'm sorry, you're buffering a little bit.
Oh, sorry about that.
So I think what your question was. We used the Navex because there was some calibration, like it took care of some calibration for sensing the position. Also, it plugs directly into the MXP port, I think is what it's called on the RoboRio.
Yeah.
But like I said, we just want to look at it to see which one's easier, more stable, and gives us the best results. So we're trying all of them. We're not counting any of them out.
Okay, cool. Sorry about that, by the way, guys. Didn't mean to make my voice go all crazy on you. All right, that's good to hear. So let's talk a little bit about vision. Where are you guys as far as vision's concerned? I know that it can be a complicated problem. I don't know if you guys have used it before in the past. Why don't you tell us about how that's going?
So last year was the year that we really started messing around with vision and using grip to help get the images all set and ready for our code. And this year it's been going a lot smoother than last year since we've learned from our mistakes. So we actually have some very key points of it done. So it's mostly just taking the information that we get from vision and using another code.
We can see green.
Yeah, we can see green. Lots of green.
Lots of green. So for those of you who maybe don't know or are watching, can you explain what grip is really quick?
So grip is like an image processing software. So if you take a video of what the robot sees, you'll get all this background stuff you don't want. You just want to see the goal. So what Vision does is it will sense the retroreflective tape. It'll darken anything else in the image other than that. So then all your robot really sees is the retroreflective tape. And a lot of teams use LEDs with green strips on them. So when the lights flash to the retroreflective tape and flashes back, it generates this very bright color, this bright green like goal in sight. So Vision just processes that. It can also tell you your center points too, which is very useful. We're using that right now as well. It tells you area, so you can do a lot with Drip.
Cool. So I guess the next question is, what exactly are you guys going to be using Vision for? Are you going to use it to line up to the boiler, or are you guys going to use it to line up to the gear post where the tape is down there?
So right now we're focusing more on lining up with the boiler. So we're just messing around with that. We're more focused on shooter stuff, as like what we did in the beginning of the year with our strategy dictates design. So we've had that down pretty well, and now we're just implementing like gyro code with it, so then we can like turn with whatever Vision tells us to do. And yeah, just messing around with different drivers to see like what's the best thing to use.
Cool. All right, that sounds good. Any other neat stuff you want to talk about with the software before we kind of move on to another topic?
Well, there is something that we've been using. If usually a lot of teams use PID loops, which help keep certain things at certain set points, depending on like if you want like displacement or like speed set points. This year for our shooter, we've been working with this code. I don't know if it's officially called this, but like bang bang drives. So yeah, so basically it's instead of like you set a set point in the PID, it's you set wherever you want your speed to be, and if you're below that speed, then you crank it up to 12 volts, like the maximum amount of power you can. And if you're like too far above, then you just cut it in 0. And that's been working surprisingly well with us.
Huh, interesting. So I got to ask, a lot of times people think of bang bang control as sort of like a step back from PID. What led you guys to want to go in that direction this year?
Well, with PIDs, it does get very tedious to try to calibrate that, and it takes a lot of time. But we kind of saw it as more of a time constraint with PIDs. It seemed like it was taking like a very long time. We wanted to have like very quick results, so we tried out the bang bang drive, and that seemed to work very well with recovering from like ball loss.
Another thing is, I think some PIDs, I mean, I know you can change a lot of things with it, but some will put on the brakes if you go too far over. Where this, it basically uses the losses in the wheel to come back down to speed instead of putting the brakes on to take you to that speed you need to go to.
Oh, I see. That makes a lot of sense. So you basically, if the wheel's not at power, it's because you're shooting. So you want to crank up as much voltage as you can to get back up to that speed, because you're losing wheel speed by shooting the balls.
Yeah.
Cool. That makes a lot of sense. All right. Well, let's talk a little bit about the not robot stuff. Let's talk about your chairman's award for this year. We know that you guys do a ton of awesome stuff with a bunch of teams in Michigan and a bunch of other stuff. What exactly is your essay looking like this year? Do you guys, I know some teams sort of have a story that they sort of tell with their essay, or they have a theme that they follow. How are you guys doing it this year?
So what's really neat is this is our 10th year of being an FRC team. And so we're kind of going back to our roots. So when we started the team in 2008, our team name is the EngiNERDS. We wanted to kind of recreate the stereotype around a nerd and show how it's cool to be a nerd. So we're doing a lot of that, breaking down in our essay to try to show the things that we do and how they correlate with how we make it cool to be a nerd again, like we said back in our first chairman's presentation in 2011.
Wow, that's actually like a really inventive. I like that. It's very like cohesive with your team's theme. Can you give me like a little like taste of what the essay looks? I'm not asking you to read the essay or anything, but like how does it all flow in a practical way with the essay? Oh, could you hear me?
It was
Say that again.
Yeah, it was buffering a little bit.
It's all right.
You sounded like Mr. Roboto.
Yeah.
Oh, sorry about that. Why don't you tell me, like, give me some examples that you guys use in your essay about how it's cool to be a nerd.
So some examples that we use are, for example, some say like nerds wear glasses, right? So we tie that in with our safety glasses. So we go in to talk about our safety program and things we do with safety. So we gathered as a team and we tried to come up with some of these names that some people say are true, but we obviously know are not true. Because even though what they say is a nerd, everybody's different, that kind of stuff. So we're trying to defy that stereotype within our paper. So it's a lot of different characteristics like that. Some may be personality, that kind of stuff.
I think another good example is a lot of people don't like to be actually name themselves after us, and they call themselves the Nerdlings. So they actually took it upon us, and they kind of look up to, I think, the high school students as role models, and they inspire to be like them. So
very cool. Well, that's awesome. I hope you guys do well with your essay. I know you guys have won the Chairman's Award in the past, so knock on wood, good luck. You guys have another, I think it's going to be due right like the couple days after check-in, right? I think it's due the 7th, or when is it due? The week? Okay,
the 9th.
Cool.
The 9th.
The 9th, that's right. Okay, cool. I'm not writing it this year, so I don't remember exactly, but cool. Well, I look forward to hearing more about it next week and how everything turned out. But what about like the other awards you guys do? Let's talk a little bit about how you guys are preparing to do other awards this year.
So some of the other awards we submit for is the Woody Flowers Award, which is where you nominate a mentor. It's very student driven. We're finishing up some final touches with that, and that will be submitted tonight. That way we can really focus on our chairman's essay some more.
Okay.
For the first time since 2013, we are also submitting for the Entrepreneurship Award this year, which is where you submit a business plan with your 5-year goals, that kind of stuff. And then we also, for each award that we submit for, to help with like the engineering inspiration and chairmans, we make engineering notebooks for both that include like our CAD drawings and design reviews that we do every Monday. Very
cool. Wow, that's like a very comprehensive plan you guys have going on. I like it. I don't want to pry too much into the particulars, but do you guys keep who's being nominated for the Woody Flowers Award a secret, or is it kind of like a known thing across the entire team?
We try. All the students write it. We get some mentor. We get like a mentor that we keep it a secret with them to try to read it over and edit it. But really, it's a lot of the students' opinions that go into it because, it's about us trying to nominate a mentor that we really see as really a star mentor and that really inspires us. So we try to keep it a secret and try to make it as much student-led as possible.
Cool. I really like the way that works. So that's why we do it. How we've always done it on my team. And it's led to a couple of really good moments. So cool. So let's round out our talk this evening about scouting. We talked a little bit about it with Cybertooth, and you guys, we're getting surprisingly close to week 1 and actually competing. So how are you guys going to be judging the other robots on the field this year?
So what we decided this year is to have scouters scout each robot on the field. We're also going to have scouters for the pilots too, so we have sheets for that as well. So we're looking more about like cycles that the robot can do with gears and fuel. Real mark to see like if they can put on a gear, if they drop gears. Also, they can successfully climb or not. This is a big thing that we're looking at.
Yeah, I was going to say we went through probably, I think we're on like revision 4 or 5 of our scouting sheets. We kind of at the beginning saw that trying to actually in normal games last year we'll mark every shot made, every shot missed, and track that. It's really unrealistic to try to do that with this year's game, with the fuel being 600 fuel on the field at any given time. So we've kind of had to take a step back from that and try to like Gus has said, look at cycles. How often do they go to get a gear to get, fuel off the ground, or, any of the other stats there. And we normally have 6 scouters to scout each robot. Yep. And like I said, we're going to have 8 scouters this season, 6 of them watching robots, and then 2 watching each of the 2 platforms and watching to see if you drop that gear or if you drop the rope.
We'll be watching.
You will be watching. I got. So
I mean, to actually touch on that point too, we actually finished our gear slide mechanism this week. Like we made 3 real ones, like out of steel and HDP and all of that. Maybe we'll try to get some pictures or photos of it and for our next video. But there is nothing retaining the spring in the slide mechanism to prevent that from actually coming all the way out the top and falling out. Like it's just gravity and the skill of the pilots. So and then the rope itself can also fall out the port and you can no longer use that anymore. So
yep, it's a very technical skill this year, and that kind of ties in a little bit to a question we got from one of our viewers on Twitch. So let's put the question up on the screen. So they're asking, to what extent do you think that picking gears up off the floor on the field is essential to performing well in matches? So do you think that picking up off the floor is going to be super duper important, or do you think teams are going to be able to skate all the way up to Einstein with just a hop delivering from the loader?
I think that it'd be a useful trait. I don't think that'd be something that's like mandatory if you want to get to Einstein's. I'm sure that they'll have teams that just have your very basic ways of just holding a gear and just cycling with that. I mean, if you're good at cycling, that's the main part, is can you get those gears there rather than like, I think, manipulation.
So I mean, the other thing we talked about this actually last week as a group a little bit is that probably week 1, 2, and 3. If you have a gear mechanism, we're in the district model, so it might be different than some of the areas. But if you have a gear pickup in probably weeks 1, 2, and 3, you will rank probably pretty high. Don't know if you'll rank number 1, but you will definitely be one of the first picks. I think in get to Michigan State Championship, it'll be very similar to the low bar. At the Michigan State Championship last year, you didn't need to have, I mean, look at Rush, who won the Michigan State Championship. They didn't have the ability to go through the low bar because at that time, it was not necessary anymore for every single member to have that feature. And if you're dropping gears at MSC, you're not having a good day anyways.
I agree with that. All right, so we're going to take one last question before we head out. This is a really important question here, coming from the Twitch chat, as you can expect. So this is Dean Kamen's Denim is asking, are 4488 and 2337 building twins this year? We noticed we got some apparel, maybe some cross promotion.
No.
No,
we don't even keep in contact with them. If we do build twins, that'll be amazing.
Yeah, that'd be awesome.
Okay.
No, a lot of our students wear different team shirts all the time, and it just happened to be the shirt that Gus was wearing today. So
I got this from Worlds.
But no, we are not twins.
Yeah.
But hey, if 4488, if you want to send us your CAD drawings, we can take a look at it and compare.
Yeah. Share. All right. Maybe they should just watch check-in. Speaking of that, thank you guys so much for being here tonight. We're going to move on to our next team. It's going to be Team 3847 Spectrum. They're from Houston, Texas. And we're gonna take a very quick break and bring them right back. But EngiNERDS, thank you so much. We hope that your robot gets driving for this weekend, and we hope that your chairman's essay turns out good.
So do I.
Yeah. Oh, yeah, I have no doubt. So, all right, have a good night, guys, and we'll see our next team in just a moment. Thanks.